All those prime university, by that they come to for masters. Any of you join them in masters, they will just flash you. You know why? They cannot, because they are doing it what? Both. But that made them a master of econometrics, you are off. When people realize themselves, it's even worse. People are still better off. So econometrics, what you do in econometrics, let me revise, just give me summary before we go to the next lectures. Anything about econometrics, what we explain more in econometrics is about the disturbances term. That is the error what? Error thing. You see, everything about life, what's your name? Kayo. When you try to minimize in life, your mistake. That is the error. Eh? This error you are seeing is what you explain, beta 1 plus beta 2. Please, I'm very fast. Eh? This error you are seeing cares about this model. Assuming your exam is 100%, the Y, and your examination, this is total score of the exam, is the population, is the PRF. The what? Why is it PRF? It's population of the exam mark. You cannot get 100 over 100 in this course. And the period that we'll get, we monitor people from now. Because when you are graduating, we have an award for the best econometric student. But the fact that the ladies are always taking the award for the past 3 years. The one that took this parallel, her name is Cadness. She took the award for the best econometric student, the best statistics student, those are my courses. Eh? The guests are always what? Taking the award for the past what? 3 years. But I don't know those who are going to take the award this when they are graduating. So, things we study in econometrics basically is the stochastic element. This error you are seeing is econometric itself. What this error is not there. This is deterministic what? Model. And that deterministic model is what you call mathematical model. Once the error is not there, but everything about life is not deterministic. There's no one like deterministic in life. When I say you are deterministic, you are error-proof. But in real life, why the Bible says all are sin that come what? That shows that in your life there is always what? Why do you go to church, mosque to pray? Or you go to church to pray? Is to minimize what? Error of life. So this error is very big. So what econometrics study more? 60% of study econometrics is about what? How to minimize what? Note that. In reality, econometrics is quite of course quantitative and not what? Qualitative. Even if you have qualitative variables, you must subject them into what? Quantitative. Why? You must analyze the parameters. These are what? Parameters. If this is a simple regression model, Duster, is it your Duster? Assuming that this was a simple regression model, the one, get the Duster seated so we can what? Assuming that this is a simple regression model, beta 1 plus what? Beta 2, S plus U. What you have to analyze is the what? The parameter. The beta 1 and what? The beta 2. Those are the parameters you analyze. It can be a multiple regression model. We have so many what? Many variables. So everything about life cannot be simple. You should know that. This is just a conventional explanation. Then in that case, beta 1 is the intercept. Then beta 2 is what? Is the slope. Mathematically, if this error is low, it's off. We have the y over what? The what? The s. This is constant, is equal to 0. This is the slope, is equal to what? Beta what? Beta 2, mathematically. But then, and this one is the PROF of the model. The SROF is Y beta 1 cap plus what? Beta 2 cap S. You can even add U what? U cap. And you can get Y out of this. This one is what? Y cap. As just to revise, a lot of you. Y cap. Therefore, Y is equal to what? Y cap plus U cap in that order. But all the same, we want to minimize what? The U. If U is not minimized, you can get solution to any problem. But when U is not minimized, the solution will not last. Is that clear? The solution will not what? Will not last. In that case, it will not be blue. No, it's not blue? Best? Yes. You can get answer. I wish we were in the lab now. I will project a solution. I will project an equation for you. You see the answers. I'll tell you whether they are good or not. You know whether they are good or not. So the U must what? Be what? Minimized. So we talk about this one much. The U must be minimized. If not, your answers will not be what? Will not be right. And how do you minimize what? The U. Use summation square. That after this, you square it. Okay? Once you square it, you are what? You are minimizing. If you don't square, the U summation is equal to what? 0. I think that is the what? Second what? Assumption. The expectation of U giving what? Giving S. I told you last week. The first assumption is what? U error is what? It's a random. It can be positive. It can be what? It can be negative. It can be 0. It can also be what? Positive. That's the first assumption of the OLS. That's error must. U is not control. You can only minimize what? U error. Minimize error. In order to minimize error, it involves so many factors to minimize error. You must have a good model. A good model to minimize error. I'll give you an example. Let me get an example I see that I can remind you an example. You want to have a good relationship. Maybe you are up to marriageable age. I want to marry as a girl. What you do is to minimize what? Error. And how do you do that? You have to look for good variables that can take your marriage into 50 years. You are still with your husband. So when you want to minimize you, choose what? Good what? Maybe the person you want to marry is a pastor. That's one variable. The man must be a pastor. Variable 1, pastor, fear of God. The man must have money. Variable what? Variable 2. And the man must what? Must be coming from America, not deploy it to Nigeria. Variable what? 3. But if you omit a very relevant what? Variable, a co-variable is omitted, like say it doesn't matter. After the man's money, is fear God, you can be a pastor, and yet you cannot what? You can't maintain your relationship. It's true, eh? Then you omit love from the relationship. Love is an important variable. Love is important. You can have money, everything. In the future, the marriage after 10 years, what runs the marriage is what? Is love. You know there. Love is a variable. What is that? If love is not a variable in the model, you have a big error after 5 years in your marriage. Because do you want to tell me that, let's do a practical example. Do you want to tell me that Two-Face has no money? But what lack in that relationship is what? Is love. So in that case, U must be minimized. Minimize of U square is equal to what? Summation of what? Y minus what? Beta 1 what? Cap minus what? In that case, you have to what? S beta 1 cap plus what? Beta minus what? Minus beta 2 what? Cap S square. Once you square here, you are what? You are minimizing. Please note, If you don't square this, you lead it to assumption 2 of the OLS. We say what? Expectation of what? You giving what? Says equals to 0. Second assumption. It means that assumption is what we call assumption of exogenality. How do you call it? Exogenality. Exo what? Exogenality is a very powerful tool in econometrics. Somebody asked the question, if you sum up the error, I wish you are in the lab now, I will run a model for you, a model of about 45 years observation, bring out all what? All the error, sum them up in a say. That's why this class is lucky. Some of them in the essay, ask yourself whether it's 0 or what? Or not. It will be 0. But then, if it's equal to 0, assumption 2, I'm just reversing of the OLS, assumption 2 of the OLS, you giving what? S must be equal to what? 0. If you giving S, let's give S. For example, you have a profit. Assuming, I told you that time, assuming you make profit, S is a profit. You go to the work, on Monday you make one can start for 100, 10, just take one as one. You can start for 1 million or what? 1 billion, then you just as one. Monday, 1. Tuesday, 2, in that what? Then Wednesday, 3, then Thursday, 4, and what? Friday, 5. And how do you get let's divide the U from here. It means that what? To get what? You go by what? It's equal to what? Summation of what? S over what? N. Meaning what? It's equal to what? 15 over what? 5. Give you what? That is the mean. For you to get you have to deviate from the mean. When you deviate from the mean, you have what? That is what we call you now, error now. God asks you to walk on a narrow path to heaven. And narrow path to heaven. And the narrow path is straight. Walk to heaven. Then don't commit any sin. As you are walking on the narrow path, you deviate. That is you, number 1. As you are moving from one year to another, maybe at the age of 50, you start what? Deviating from where? From the what? From the mean. The mean there is 3. The 3 is always a straight line. Okay? Once you are passing through the mean, when you deviate, you are committed what? Either the error is positive, or is what? Negative, or the error is what? 0. Where will the error be 0? You commit. Where with the error, you have no error. 0, where you commit. If you are walking, if you deviate from the mean, where will the error be 0? For the mean here is what? 3. Where will the error be 0? It means that, let's draw another graph. S minus what? S what? S bar. What is 1 here? 1 minus what? 3. 2 minus what? 3. This is what? Minus 2. Minus 1. 3 minus 3. You see, this is the mean. And this is 3. Now, when I say come to this class now, the class is 12 o'clock, assuming. Let's assume 12 o'clock. When you come exactly 12, your error is 0. 12 minus 12 is equal to what? You came 12, and the mean is what? 12. 12 minus 12 is 0. But when you come 11:45, where is your error there? 11 minus 15. When you come 15 after, where is your error there? 15. We are going to enter that assumption right now. If you watch here, 4 minus 3 and what? 5 minus 3. This is 1 and this is what? 2. These are the errors. U1, U2, U what? Sum them up. The summation of all the U giving what? 0. This assumption, you see, summation of U giving what? S. You cannot get U before. You cannot get U until you get what? S. This is 0. This assumption is called what? Assumption of exo what? Generality. It means that in any model, please note, exogenerality means, see, exo. Let me give you more exo for it. Exo is a powerful thing. If it's not exo, if you sum them up and it's not 0, that means it's another, that equation cannot be a single equation. The equation will lead you to what we call simultaneous equation in econometrics. If you sum all the U and they are not what? 0, Let there be 100 errors. That means that there's a violation of what? And the violation is called that the U has something to do with the S, which someone not to be. Look at it. Y is equals to what? Beta 1 plus beta 2 S plus U. This is going to be 0. If it's not 0, that means the U and the S, they are correlated. They are what? Which is not supposed to be in a model. The U is supposed to be on its own. S will be on its own. Assuming you are a man, this is Lawan. Lawan is a man. Is happily married to what? To this, to a woman. Or Mary. Listen, to Mary. Mary gives the happiness of Lawan. Is a function of what? Or the wife. The wife is an independent what? Variable. The wife happiness depends on what? The behavior of what? On the wife. And the you that Lawan has is the side chick he has. Okay, the side chick and what? And Mary supposed to be what? Independent. Don't explain what each other. The day that the you explain what? The S explain what? The you, they both know that model cannot hold. The assumption is what? Is violated. That in that case, please look up some exam question that will define you. In this case, this Y here, the Y is stochastic. The Y is what? What may want to be stochastic? Y as if this S here is called fixed variable of the model. It's fixed. It's already there. It's there. It's always what? There. Try to explain what? Why? This U must be there because of the way of life. No one is what? Perfect. It must be there. Because the error, it can be error of gambling now. It can be error of what? So many life what verses. Then you find out that in that case, this Y is stochastic. Why is it stochastic? Because it's explained by independent variable and also what? An error. The S is not stochastic. Note. Because S is not explained by what? It's not explained by what? No, S is not explained by the error. Okay. Once you are not explained, it's the error that makes it to be stochastic. Once you have error in your life, you are stochastic. Once there's error in your life, you are what? What is stochastic mean? It's because of the error you are what? Because the error makes it to be either positive or what? Negative or this is. So that is stochastic now. Once you have error in your life, you are like a drunkard. If you have a drunkard to move here on a straight line to that line, the person is drunk. He cannot. The drunkard will be what? Moving what? In a stochastic what manner. He will come here and agree this one. He will come here and what? He can't move straight. In that case, stochastic will be like drunkard. So if Y is stochastic, but S is not what? Stochastic. Why is S not stochastic? Because S is not explained by what? By the error term. But the day that means that if S stand alone to explain Y, you stand alone to explain Y, they are both independent. But a day that both of them are where they are in the same what? Equation, and explain each other. The day that S is stochastic, the equation in that becomes a simultaneous what? Equation. And it has violated what? Assumption 2, which says what? Explanation of U given S, it cannot be equal to 0. It cannot be what? Equals to what? We will see the assumption 2. Then number 3 assumption we have said so far is the assumption of what? Of the homo what? Homo means equal what? Equal variance. Homo means equal variance. Let me explain to you. I give a grace of you coming to this class. A grace of 15 minutes. How many minutes? 15 minutes. That's the business. This class is 12. Then, and this 12 is a straight what? No, everybody cannot fall with what? This come by 12. That's the meaning. And I said, if you want to come, here will be open for you by 11 what? 45. And be close to you by what? 12 what? 12, 15. That means that if you come by 12, you come by what? This is me, okay? You come by 12, you come by 11:45, you are what? You come by 12, the error will be what? Lying what? Once they are lying with this range, these errors, you sum them up, let there be 1,000 error. When you have what you call equal what? Equal variance, the summation of the error, given S must be equal to what? 0. That means this is called equal variance. Listen to me. If you are equal variance, you are a little bit deterministic in life. Somebody can predict what? Equal means you vary off by minus 15, plus 15, or plus 15. You that vary off with 0, you have equal variance. We tell you that vary with what? Minus 15. We put there all the same what? Bracket. If you are doing econometrics and apply econometrics, it will draw a line. I will show you from the line if you in the lab. It will draw a line on equal what? I will show you. I'll read it on the board for you. See, you have some errors should stand between what? The mean. There's a what? A gap. A gap. For example, this is, I say move to that basket, which is on this line, a straight line. Move on this straight line exactly. There's a straight line here. Move on straight line. But no, see, it's not possible for you to move on this straight line. You may be what? Moving what? Moving out. Okay? And that's okay. Here is the range. Between here and here, what? Range. You can have it will give you 0 range. It can give you minus what? Plus 5 and what? Minus 5. That means that your error should not go what? Above this minus 5. Should not go what? Below what? All the errors that fall between 5 and what? 5. Sometimes they can give you 2. 2 and minus 2. That range. Error you commit should not go above what? 2 and what? If you fall, even you fall here 0, you fall here 2. Get me? It's all equal what? Variance. Means that you have the same error what? Type of what? Error. So ALS, we run the model without error. When the errors are what? You can predict these errors. The errors that have equal variance, you can easily predict. Then, if you know somebody is in school, a lady is in school or a man in school, and you know the work to the class, to the library, what again? To what again? You go from class, go to the library, you go to the cafeteria, or you go to anywhere and to your hostel. You know that person, you can easily, even though the mother is at home, or the father, the parent, they can predict what? The movement of that person. You can even say, my daughter, my son, no. And know where they can go to at this time around. Library, what again? Class, what again? Just in that order. But that the person has equal what? Equal variance. Because it's predictable. In that case, you will say that the assumption of you giving what? S equal variance is homo. Please look at homo. Homoskedasticity. This is how you write it. Homo what? Equal variance. That symbol. When I say that symbol is homo variance, you square what? You square the row there. That's homoskedasticity. But see, if this assumption is violated, it becomes enteroskedasticity. What is what? What do you mean by entero? Unequal. Is that means that so people can come to this class at 2 o'clock. You know, they have error of deviation now. If the time is 12, minus 12 away from where? 2 o'clock. You can see the error is what? Is big. Outside what? When you are outside, nobody can predict you. Because what? Entero what? That means that unequal what? And the entero is written in this. But if you enter this way, this subscription mean. This observation means that the observations are not what? They are not equal. That's the meaning. Observations are not equal. See, look at it. Homo and what? What is the difference between homo and hetero? Just this subscription. It shows that the observation, the error are not what? They are not equal. Some are what? Outliers. Far away from where? From the mean. Enteroskedasticity and homo what? Let me give you a life example, which I've observed. You have stores that says the same product. There's a store I normally buy from in Benin, House Fitis. electronic analysis. Then some stores, there are other stores out of the store. One of the stores very big, very big. He said what others 8 stores also what say. Those fit is now. When you get there, assuming those 7 stores, they have average profit a day, maybe 89. How many stores? Let's say 6. 80, 90, 91, 88, and it can also be 79. You can see this is the average profit of all what? Store 1, store 2, store 3, store 4, store 5, and what? Store 6. In this case, assuming that they pay daily tax for selling in government what their tax is daily. Okay. This one, when we measure this one, they will have equal what? Equal variance, because they are what? They are homo. You somehow for you to know they pay some of the all of them and find what? The mean. They separate that away from the mean. There's some of all the errors of what? Deviation. They say they should pay 5% of the of what? Of the mean. 5% of the mean. Who has finished that? So people are looking at me. Who has finished that? What is 5% of their mean? 5% of their mean. Favor, you are not finished. 5% of their mean. Who has finished? One what? What's their summation? What's their summation? 500? 510? Oh, 5 what? 517. 517. But see, what is their mean now? 86 point what? 17. Okay, let's say 86.2. Then that minus 86 point what? 2 in that what? In that order. That's their mean. Okay, let's just start me. Don't for the deviation. You find out that they will have equal what? And 2, now for 86.2, 5% of it. How much is going to be that? 1 point what? 1.31, 4. 1.34. 4.34. Okay. Okay. 1. Oh, people are talking. 4.31. Okay, good. Okay, in that case, this is their mean. So, okay, each of them should pay 4,000 a week for using government what? No one will complain. Will they complain? Is there any complaint here? It's not complain. Because it's what? It's fair enough. Assuming that store that is also very big, because it's a store also there, it makes 3 million a day. I mean, a 3 million. This one will cost entire what? The error will be so what? Because when you remove this error now, they'll be very small. This minus this, you have 3 something. Minus this, will be very what? Very small. But when this one enter, this one error will be what? Will be large. This one is an outlier. So outliers always cause what? Larger errors. And that larger error will spoil the mean of what? Of the error. And that is an entire what? Assuming you ask Joshua, Lawan to fight with Attorney Joshua. Attorney Joshua is an outlier, and Lawan is what you found out it's a big one mismatch. In that case, you have a problem of entero water. Entero is not allowed in econometrics. It's one of the problems of water. Even though you have results too, but once there's entero, the analysis is not blue. It's not what? It's not blue. And the results are not valid. The results are all what? Unbiased. They are biased instead of what? Unbiased. Why? Because there's a problem of water, entero water. The margins are okay. After putting 3 million, You now find what? The average. Please do it for me. Put 3 million. That is, what is the result of that? 5 what? 5 what? 517 plus 3 million divided by 7. Look at what it will be. You find out that the result is not going to be what? Because of what result of. What does it mean? 400. That is too big. You see, even the me itself is bigger than is. If you put a big what? Big errors. What inflated that error? What inflated that error? Because of the outlier. In that case, your OLS cannot work. No, but assumption for the OLS. And for example, it's assumption of normality. Normal distribution. And how do you measure normal distribution in real life? How do you measure normal distribution in real life? What is the measure of normal distribution in econometrics? Let me ask a guy. Okay. How do you measure normal distribution? Okay, I've asked you before. Question. Okay, I want to ask. I don't know anybody in this class apart from Lawan who always score. Huh? Okay. How do you measure normal distribution in real life? How do you measure normal distribution? As Oshofan said that the error, please note, the first 5 assumptions, the assumption about what I told you. We are seeing assumption 4. Oshofan said that the error you get must approximately what? Normally what? Normally distributed. When I say it's normally distributed, it means 0 mean and constant what? Variance. Any model that has 0 mean, that's 0 mean summation of x give you a mode 0, and also asks for constant what? What is constant variance? The model has almost what? Almost scalarity is normal. Is that a key? When you run the model is normal, means that the model has what? 0 means and what? A constant what? The model is hard. He has no problem of entero. He has no problem of what now? As the what? Exogenality. He's free of exogenality. Also free of what? Almost contact-activity. The model is normal. But now ask me a question. How do you measure normal what? Distribution. Normal distribution is measured with what we call. We measure it using histogram. Using what? Histogram. We use it using what? Histogram. When you say histogram, which you have covered before, whenever you say histogram is used for measuring what? Normal what? Distribution. Maybe you don't know before. And how do you measure is? You look at the skewness to what? To the left or to what? But in real life, there's no word like normal water. It's only in theory. We have to call, which we are in econometric lab. I told you, I will just draw for you normal distribution. Look at it. It's only in theory. We have normal what? A man that has 2 wives. How do you measure normal distribution? It's a question. You. Is it real in life? No variable is normal. Is that you want skewed to what? Or skewed to what? To the right. Even when you are children, you can't say my children are given equal what? Equal love, equal attention. Is it possible? It's not possible. Why is it not possible in the Bible? Why is it possible what? In real life. You must what? Love what? That's not equal. That normal mean bell-like shape. If you have a bell-like what? I can't draw normal what? Distribution. Equal what? Please note, here is 0. Like what we proved just now, S 1, 2, 3, 4, 5. What am I? We have minus 0, minus 1, 2. The one also 1 plus 1. That one is a normal. For to have a normal distribution, your life in a way must involve a linear life. Is there anything a linear life? No life is linear. No life is linear. And in a way, no life is constant. Life is not a linear function. It's not a constant function. It's not a linear function. Even life is not even a quadratic function. Life can be what? Let me give you five functions: linear, constant, linear, quadratic, cubic, and quartic. Quartic is to the power of 4. You are checking your head. Your big head. When they mean that life is not what? Is not constant. Constant function. Constant what? This is a constant function. You remain at the same what? Irrespective of the change, you remain the same. There's no life like that. Life is not linear. This is a linear what? Every day you grow, you are growing up. No life is like this. No life is what? If life is linear, like straightforward, that means that your life is free of what? Stochasticness. No, there's no error. That means deterministic life. So, life is not even quadratic in nature. Either like this or what? Like this. This is a quadratic function. Raised to the power of 2. Raised to the power of 0. S raised to the power of 0. S raised to the power of what? 1. S raised to the power of what? 2. That's quadratic. Like if life is quadratic, say purpose life is quadratic, like this. They are rising up, and they get to their peak. Something, there's a shock. Something coming down, and you die. I always have example. Like that mother died. Is it Ada? Ada. That actress. What's her name again? Ada what? Ada. There is now. She was growing up. She had a shock of her life. Her daughter died. She went into what? Depression. And she never came out. She died into depression. It's late. It was last year now. Is that woman called Adana? You know the woman? What? It's the Johnson. People don't follow stress. She died last year. The only hope she had was her daughter. That's a big shock of her life. Okay? The daughter died immediately. She went into what? Depression. And she never came out of the depression. That means that her life was what? Quadratic. Because she was rising, and went to what? Get to what? The 1 year is equals to 0. Shock. There's no change. She now what? For the shock, she was now what? Her face started to make her up, but she know what? And she what? That is quadratic life. Another one is that you start from the peak. Your father is a billionaire before they born you. You are rich. Immediately that your father died, you what? You start going down. But as lifetime come up, you what? You go up again. You can't go forever. So life is either cubic or quadratic. Life is like this. You rise and what? You rise and fall. Even business like that. Business cycle. That's it. Business go and what? And fall. So no life is what? Therefore, normality test. Number 5 assumptions of the OLS. Are you with me? Yes. Assumption of no autocorrelation. No auto what? Are you following me at all? Assumption of no what? If you are using OLS and the OLS to have good answer, there should not be what? It should be free of auto what? Correlation. What's autocorrelation is when the past errors explain the present error. Your past error explains your what? Do you know that the kind of family you have? After if something happens in the family, they'll say, your father was what? I think I'm right. They go and say, your father is what? He said, no. He said, no, look at it. Let me give you an example. I met a woman. The woman, she was crying, and I asked, I said, Mother, why are you crying? He said, my daughter is just disgracing me. disgracing me. What happened to your daughter? You must say that a daughter just put to bed and they don't have money to what? To take care of what? I believe a life thing. Then another woman called me, say don't mind her. Now so the mama table now. That means that the girl was born outside what? Wedlock. And the child that you just gave birth now outside what? Wedlock. That means that the past error explain what? That's auto what? Auto correction. Auto correction is what about the error. When your past error explain what? Two things are involved in auto correction. Two things are involved. One is involved. Your previous error and what? Your correct error. That they should not explain each other. For example, if I enter the kitchen sometime, my own kitchen, I find there's a split of meat on the floor, I will not ask what? No, meat on the floor. Somebody told me and there's splat it. I will ask who poured the meat. I will just call my last daughter. I know she's the one. Because that's where she what? Once you take me, we just what? She's so fast and she will not just clean and just because she's so small. So that means that autocorrection has to be with what? The covariance, please. It's about the covariance, okay? Look at what I said. I think we have the error now. U1 for that one, U2 and what? U3. We have first now. You can add error out of 4 errors. 1981 to what? To 2020 data. The data from CBN. You know you have data of GDP, okay? For you to get this error, find the mean of what? Of the GDP minus away from what? You get the errors. From that, from there to here, it's going to be about okay. That's for the 3 observations. Observation now. If you are born here, you are what? You are for 3 years now. Okay. Then, at each of the year, as so what? Error. And as you get the error of the year, the mean divided by what? U1 to what? U what? U43. U1, U2 in that. Okay, let's say U1, first U is UI. Second U is what? U what? UJ. UI are what? UJ. Let's use only these two what? These 2 errors. It means that the covariance between UI and what? UJ, between the previous error and what? As if this is what this kind of error. Okay, let's use this one. 2022 and what? 2023. UI and what? UJ. The covariance between UI and what? UJ, giving what? SI and what? SJ. No, SI, SJ must be equal to 0. The covariance. What do you mean covariance? Where 2 things are involved, we talk about covariance. What difference between variance and covariance? Can you tell me? Difference between variance and what? Covariance. Quickly, tell me. Who can say that? Who can tell me different? When you feel different, you come and take notes. If you get the answer, come and take notes from my office. When after the lecture, you come and take notes if you get the answer from my office after the lecture. What's it? Yeah, try.
So variance is like the deviation from
covariance.
So covariance is like
Yes.
two
Covariance. Variable. Okay.
variables, and then we're probably giving the true parameters
Okay.
and then the estimates.
Okay.
Then we now see that.
What about the variance?
Yes, the variance is just the actual deviation. Then the covariance is deviation when we are giving
2. Oh, she just have 15 over 100. And you see a mod, You see a mod, okay? Then, when I mean covariance, I like giving an example. Probably I'm walking alone in a narrow path. Now, I think just say, the message you send yourself, you are always faster. Than what you say what? Somebody. The message you send yourself, you'll be faster than the one you what? Send what? You say somebody. For example, I want to take something, that basket, that yellow basket from that place. I say, this guy, go and get it. Or I should go and get it. You know, to and fro, it can take me, for example, 4 minutes. Okay? You have me to back here 4 minutes. I can get it. I will come back in the next 4 minutes. Maybe I can be above 4 minutes a little. 4 minutes is the mean. Okay? I can go back, come back, maybe 4.2 what? 2 minutes. That is, I'm deviated from where? From the mean. My variance will be very small. Okay? That is variance. If one variable is involved, you calculate the variance for what? That variable. But if I say, this ball, let's go together and go and what? Come back. And we must come back together. Let me say, I'm faster than this boy. This boy is what? I'm going to adjust to what? To the speed of what? Of this guy. Maybe by the time we go and come back, you are taking 6 minutes. Why? Because this guy is going to add his whole error to what? To my error. The errors are going to affect what? Each other. And then we talk about covariance. Because what? Two different errors are what? Are involved. His whole error plus my error will what? Will affect what? Each other. So that is quite bad. Because two things are involved. Two things are involved in two things because what? They are very become what? A covariance. But when you have only one variable participating, is what? Is variance. Because one variable don't have any what? Any I watched something on TikTok. They were doing the race, and the first guy that went for the race was so fast that, and the guy got there on time and returned the back to the other one, and the guy got there, the partner has not even what. As for returning, he made the partner halfway. There, he now get the back to what to the girl that was there, and the girl was running. She fell. In fact, 3 people went to the other this thing and came back, and the girl was still running. And the count is going to be the count for the, not only for the first guy, for that group, for that entire group. And the comment will say, "Ow!" They say, someone will say, "I pray that I will not meet this kind of woman in my life who waste my time in life." No, it's this kind of partner is not what? It's not worth working with at all, because it will slow down what? The value movement. So the covariance. Okay.
So question for previously the question.
Okay.
Like a previous error, and then they now ask you this new error, is it related? And since there's no relation, would we now say this is just problem of autocorrelation explaining this covariance, or would say there's probably a positive relationship according to your analysis, or a negative relationship?
Okay, let me end the episode. I'll answer that question. Look at it. If you have yesterday error, be explained by what? This, it means that you model error. Today's error is equal to what? Explained by what? Yesterday what? Error. Plus what? Today what? Today error. See, today's error is explained by what? This yesterday. 3 minus 1 is what? It can be last year. Depending on what you are what? Using. If today's error, this today, this is what? Yesterday, this is tomorrow. Today, yesterday, and what? You can use year. This year, last year, next year. If your today's error explained by what? Yesterday error, you have a problem of auto what? The errors are what? Auto-correlated. The errors are what? Auto what? Correlated. That the error explain each what? Each other, which I want to be in any model. It's a violation of OLS. Okay, any question?
How then did covariance come in?
The covariance, 2 errors are what? Fighting. 2 errors are what? Today error is so like yesterday, so 2 errors are what? Are moving together. So it's a covariance because two errors are what? Moving what? Together. That's why it's a co-what variance. Now we're done with the assumptions of the OLS. I mean of the error what? Let's go to assumption that concerns, which I've already explained briefly, the variable and the error. The variable, clean the board, you that ask question. Because there's no, I'm just sweating. I think I need water to drink because of this thing. Please, who know my office here? I know. I see your face already. Take. We'll be very fast. Don't go together because you have what? Why should watch it? Okay, you run. You're a footballer. Come out. Let me bring one to my office. Get water from the fridge. Get water from the fridge. Fast. I'll wait for you. You have only 4 minutes. I will still repeat it. Let me write on the board. Assumption 6. Assumption means the variables, not only one variable, any variable or variables in the model has something to do with the what? Error what? The relationship between the variables, the independent what? Independent variable and the error term should be equal to 0. Assumption what? 6. The relationship between what? Independent variable. Please, listen, not giving. Assumption 2 is giving. Assumption 6 is not what? Giving. You do not calculate U from S in the assumption 2, you get U from where? From S. But in this assumption, it's going to be the covariance between what? Between S and what? And U. How the S are you supposed to move together in what? In the model, covariance. Assumption 2 is not covariant. Assumption 2 is what? Explanation of what? U giving what? S. This is solving. The assumption 6 is the covariance between what? S, comma, not giving. I tell you that these are very powerful word statement. This one you see is what? Very what? This conditional. That is what? Everything by econometrics is based on what? Conditional. It's conditional. So that stock you are saying there now is a powerful tool in econometrics. Look at it very cheap. It's not. This tool you are seeing is called what? Conditional. And in life, believe by conditional. There is no that music that says that give me your unconditional love. Who said that music in the world? We're not born. I was very small. Who's the Sonny what? Thank you. It's not Sunday idea. It's America what? Give me your unconditional love. It's Tony Summer. I think so. I bet browse it for me. This is a class. What's the answer for me? Just browse the author of Give Me Unconditional Love. Let me see it. I think it's Tina what? Tina Summer. Okay, Donny Summer. Yeah, Donny Summer. So, in that case, everything in life is what? Most are conditional. Giving. In that case, assumption 6 is not conditional. It's the covariance between what? S and U must be equal to what? 0. If the model must O, it's not conditional. It can also be, we can also tell it to be exogenality also, which I said today. It means that if you have beta 1 plus beta 2 S plus U, or you have Y, let me just say, let's build the model with model Y to build it like one. A man's happiness is a function of what? Beta 1. Beta 1 means that if all those variables do not exist, the man will still have what? Element of what? Happiness. Plus beta 2, let's put the Y first. Plus what? Beta 3, money in the account. Because you have a good wife, you have money, okay? Money. Plus what? Beta 4, you have good children. Good what? Good children. Not just what? Good children. Good children. plus what? Let's say that those are the things that make what? A man to be happy. It means that okay, what's your error, your model? Let me know. Let's take the error as what? Let's give me my error. A girlfriend. It's an error. Do you know it's an error? Because those are things that explain this happiness. It means that these are the S now. S is S1, S2. It can be only one S. S3. The S1, S2, and what? S put together. The covariance between there and what? And the U must be equal to what? 0. They should not move together in a model. That's assumption is very powerful. Let me ask you a question. Okay, let me ask somebody who's at the back. Assuming, you know, this guy that this one, if we are aware that one has what? A wife. But the wife is not aware what? That's the no information. When it says equals to 0, mean S and U don't have what? Information of each other. For that assumption to for there to be peace in that house, S and U should know what? Should have information. You can know that S exists, but S don't know what? You what? There'll be peace, the man will still be happy. The man will still be very happy. The man will be enjoying his happiness. Okay, in that case, the covariance between S and U is equal to what? 0. No information. But if it's not equal to 0, that's it. S are aware that U exists. You are aware what? What happened to this OLS assumption is violated. That OLS assumption cannot hold. It will be broken. It will be what? Violated. Once it's violated, the model become what? A simultaneous equation model. In that case, the wife will form is our own model. Make me happy, yes, and make you what? Happy. I think it's not simultaneous now. I think it's not simultaneous. Y is a function of S. S is also what? A function of Y. It's simultaneous. Why? Because of what? Assumption. What? Go on.
When the model becomes simultaneous, so are you going to split it apart and then
You don't know that assumption only because when you do your master, you know simultaneous equation modeling. It's a very complex model. You split apart. You not OLS can no longer work under what? That you have to use another what? Another method. A 3-stage least square, 4-stage what? Least square, because you have to put some variable in position. When you say, look at it, Y is a function of what? S. S now is now a function of what? Y. This is a simultaneous equation model. They have to run together at what? Why? Because of what? There's a problem of what? Exogenality what? Exogenality. Yeah. Now, if it's a problem of exogenality, that means that both of them, you explain the variables. You what? Explain what? The variables. That's assumption what? 6 of what? Of the what? Of the OLS. And look at ask the question. There are 3 things can happen in this assumption. 3 things. If let's use that the one only S, this simple equation model. This wife, this Lawan, your wife and the error term know each other now. Assuming the error term, the S and the what? The covariance is not equal to what? 0. They know each other. Their behavior can be positive. Both of them. Their behavior can be what? Negative. Their behavior can what? It can be what? 0. When their behavior is positive, it means that as S go up with happiness of what? Of what? Positive. The wife also what? Go up with happiness of what leads to that? Ask a question. Question. If it happens that your husband, girlfriend is one that gives your husband contract to gain about 3 million a month and bring to the house, and you are aware that your husband has a girlfriend, what will you do? It's a question I'm asking. You know that your husband has a side chick, yes. And your husband side chick is what I give. Please, he said, You will see the exact question. You will be confused. No, quick quiet. Go and look at my past questions. You know what I said. Your husband has a side chick. You are aware now. The conveyor between you and your error. You are what? The information is where. You said my husband is a side chick. I'm going to kill my husband. But you get told. Your husband told you that my side chick give me contract of 2 million every month, and I bring all the 2 million. What will you do? No, it's a question. These are life things. I see a man, the wife encourage the man to follow the girlfriend. You know why? Everything about the man, the cars in the house, the woman is a multi-billionaire. It's the woman that what? The girlfriend that supply what? In that case, as the girlfriend made the man happy, the wife also what? Made the man happy. That's how I thought. That's how the relationship be. In that case, when they are positive, when the three things happened, as S go up, why what? They go toward the same what? Direction. Because if you said you go against that girl, that means there's no food at home. But it's still error. You see what? Error. But just that the error is what? Positively what? Your error will not be like that. That girl from University of Lagos that killed. What's his name? What's his name? Remember that girl? Number two, the error can be negative. They can go also the opposite down. Especially when the girlfriend has only to provide for Lawan. And you only take what? Collect for Lawan. There will be war in the house. Do I say, if you don't leave that girl, I will die, I will kill you, or you kill me. They have inverse what? Inverse there. But there's a time that there's nothing, zero. But that see, say, no, the conversion between S and Y and S what? S and U will be what? Because of zero. That for OLS to what? Oh. Assertion 7 on the OLS. Assertion of endogeneity. That is endogeneity. That's the convariance between what? The convariance between S. Number of S. S and Y should be what? S and U should be what?
Zero.
Should be zero. That does not have any relationship. Yeah, does not explain. Does not explain what? You should not explain S. That's the meaning. You should not what? Explain S. That is the correlation between should be zero. When you explain S, what happened? That model is what? Violated. It becomes what? A simultaneous what? Equation. And I told that three things can happen. Let's say two things can happen. It's either both of them positively explain Y, or what? Inversely what? Explain Y. But I told you the situation when both of them can possibly what? Explain what? Explain Y. So in that what? In that order, assertion 7, you should don't have a raw functional form. Assertion of functional form of the model should be right. Functional form. I'm going to stop at the last assertion 8. Remaining one for us. Assertion of what? Functional form of the model. The model should have a good functional form. Good functional form of the model. That is, the model should not be misspecified. Specification error should not be there. How do you call that? Specification what? Error. Okay, you got a question?
Based on number 6.
Number 7, no misspecification.
Number 6 says that X and U must not explain each other.
S or what?
X and U must not explain each other.
Must what?
Must not explain each other.
No. In the model.
When they explain each other,
Violated. Yes.
Either it's positive,
Oh, yes.
negative,
One, yeah.
or zero.
Or-
But when it's zero, does not mean that
Zero, we don't count zero. It can count zero now. It can be zero. It doesn't.
that there's a relationship.
There's no relationship. No relationship now. The correlation there. When there's zero, what does that mean? Is there a relationship? When there's zero relationship? Means what? Miss But by the time this laptop. So it means that what has happened now is a problem of what? The very perfect information about what? Each other. So it's perfect. So John will actually go for the wrong, wrong person in that way. So, but if different area, then that information will not work. Something can visit you understand. I don't know if it's not the same that's because right? But especially when they have a doubt, but you say have a doubt, it's not to do what for you, but it's that element of doubt. But in this class now, perfect what? Information. They are crossword. We measure, we have to measure the relative with what? We want to call VIF. VIF. Various what? Inflation factor, VIF. Variance deflation what? Factors. VIF. You want to go to the extent. Very well, we're inflated. So that's what the problem of what a multi-coloniality. That's the problem of coloniality in the model. That one, if you are done, let me know. Huh? Okay. Various what? Then these are the assumptions of what? Of covariance. They are dependent on each other. No, they are dependent on each other. They are dependent on each other. Please, in the assumption, each of the variable should stand what? If one is not it can be that only two variables are what? Have a problem of what? For example, it can be two for this class and one for education. You understand? Even in this school, it's a very small school. It's a very what? It's a very small school. There will be a kind of a multi-water what? But if you have one, two here, you have one in education, it might be the two here, they are fighting, the other one is what? It's just on their own. So it depends. If you are available from the same source, if you use M1 and M2, the model, money supply or what? Raw money supply, you have a problem of what? What you are picking, what is wrong is that there is a perfect multi-what. If the method is always there, then it doesn't work. Perfect means one. Perfect means you have correct information, no zero error. Correct information about somebody and what? Lord, it doesn't the person, your friend will see the person. They say, I saw this friend, this guy giving what? You're giving your friend something. Your friend, so that happened. I saw what? There's a guy, a son of a musician. They are created at the 1940, I think so. He was in sociology, and another guy was in economics and dating. And after that guy that was dating, the guy was very close to me. Then and the guy will become my office and discuss at all. And the guy they were even dating, I think she's information of the people because she sells online food. Yeah. Then I told her that don't put mine. And the guy was taking another day in education. One day, in the night, the girlfriend of that girl, who was in economics, the girl of that girl in economics, saw the guy in the hall. And she came to tell us, I saw your guy in another law. And it become a war, two wars. A real what? A real fight. And at that time, this phone, what I mean now, that guy was training, you guys, right? And she bought the BlackBerry for the girl 100,000. When they're not fighting, he said you should return what? What? That's the point of what? Not what? Because the guys say what? So the boy is something I was told that go to class to take one, come here alone. Take one. Go to the bathroom, take one. There's no one reporting one there. Go to what like guys. That is what I don't think now I can't submit of so because I say already. I will I don't stay Lagos, but I go off from there to Benin, come back to enjoy myself. Okay? So what I'm going to do now is that maybe I will tell Professor Joy to take you from here. All we are taught, me know. And so I'm teaching you. What's going to that? Listen to me. We have been teaching. What I don't understand. Not let me do fact and football like that. All right. Okay, please, any picture that and you don't understand, let me know. What? Time series? Oh, say time series without the gap. In 5 minutes, let me just say time series. Time series, we have 3 types of data analysis. We use economics or econometrics. Or we use worldwide. We use economics, finance, and all. Number 1 is what? Time what? Time series. Number 2 is what? Cross section. Number 3 is what? Parallel what? Data. In the what? What is time series? Data you observation from one period to what other period. Time series data. Let's try to data. Time series can be, you can have time series of annual time series. By what? By annual time series. Quarterly time series. Daily what? When you go from one time to what? Another. In a sequential order. For example, 1981 data, 1982 data, what? That's a kind of. That's a time series data. You can never see time series. Or you can take it by annual. Every 6 what? 6 months. First 6 months, first 6 months. That in a year you have 2. If 1981 to 2023 is for 3 years, yes, the annual will be what? 86 years. 86 observation. Yes, quarterly will be what? Times 4. Quarterly times 4. Daily, you can't really calculate for stock market. Daily calculate 24 hours calculate. First hour, second hour. There's not a thing except hour. Third hour, fourth hour, in that order. In that order, calculate. That is time what? There are the time series of a minute. So it's not says every minute is 24 what? Is 60 what? 60 minutes. What happened in 1 minute, 2 minutes, 3 minutes, that's the time what? That's the time series. As far as time is what before, you don't repeat is a time what? You can have a time series of 100 years. 100 years. From next one to 100. Time series. But time series is quite what? Any question? Go on. I'm not finished. I didn't say question. Then cross sectional data. This is cross sectional data. The sectional data is what happened at a particular period. You don't want. You must say, I want to compute 2023 or 2024 observation about Lagos. What? 24, one time, that's not enough. You take a particular point in time. You don't take 224. Okay, so what to compute? For example, I want to say what happened in part of Lagos. Just annually, 2024 only. You like to add these observations. You now have Lagos. For example, how many people went abroad? Abroad people. Abroad. Private primary school. Government what? Primary school. Houses. People that live houses per 4. Not only 4 or 5. They are not more than what? You know there are some houses that are so big between 1 and 5. Houses. Between let me say 1 and 10 in the house. Houses between 15 and what? At 200. You want to know? Just 2044. In terms of areas, Ikeja, Ebariga, what is it? Mowe, all the mistake, then Lekki, now, in terms of area, you can add area of that. They got 50 areas, 51. Then NACOM, cross-sectional, is a cross-section of the globe. Abroad, people that go abroad, in Kenya, a year, for that year, 500. In Bariga, 5. Lekki, 1,500. Then, what is it? Put on the, look at that. 2 cross section. Then we got to private primary one. 2. The Ikeja, how many go there? Just a 20. Then Bariga, 5. 50,000. No, sorry. Private. The Ikeja, private. 20,000. The Bariga, private. 10. Lekki, 5,000. Then you now go to government. Ikeja, 20. Bariga, 10,000. Lekki, 1. House that you have between 1 and 10. Between 1 and 10. Ikeja, so many houses between 1 and 10. There can be 5,000 houses, 1 and 10. Bariga, only 2. Then Lekki, 10,000 house, 1 and 10. Then house that about 50 and 100. Ikeja, 5. Bariga, 50,000. Lekki, 1. If I struggle, only 1 from 9 years. Then, final data, want to look at the personal data for 221 hours. Let's have 222, 221, 221, 4. This is time and also what? Like just both time together, That's any question? Question? Last question. Last question now. What about answer question? Okay, let's explain how to do it. Let me give you last number to tell you that you want to choose. Please, I want to look at properties of the blue properties. Blue one. Check your book, is there. property, the dorsal marker. Thank you for reminding me.
Yes.
Dorsal marker theory. Your least square estimator has property. It means that what the least square, in order for it to be blue, what is blue here? Best linear unbiased estimator. Best linear unbiased estimator. You see, OLS can no longer be used, but we teach it as a conventional teaching. That's why it's called through with this lab. You see what we are doing here. So OLS can no longer be what? It's not longer best what? Linear unbiased estimator. Because most variables are not stationaries. Are not what? Stationary. Before you can be best linear, the variable must be what? What variables are stochastic and not what? So OLS this day is not what? They use. But we still teach it because it's the basic, the foundation of any other what they use. He has about 3 properties, only 6 properties. The method that you will use of possess what? This what? This property, only 3 properties. Number 1 property, the property of, that means that before you can get best what? Linear unbiased estimator. Best linear unbiased estimator, which is a beta what? Beta cap. That beta cap is using what? Only 2 what? Only 2 variables. Please go. Yes, you can put alpha, only beta. You can use what? Any what? Alpha, you can use A or B. Instead what you want to use. Beta 2 cap, S plus U. No, estimator of this is what? Beta 2 what? Cap. For you to get a good beta 2 cap, you must add this what property. Number 1 property, the property of linearity. The property of linearity. The model must be linear. Even if the model is cubic, you must linearize what? Let's look at the power of 4. You must what? Linearize. For example, a model like this, y is equal to what? A, K, alpha, L what? Beta, and U. This model is what? It's not linear. This is what? This is a conductless what? You must be linear before what? And you must drop what? This what? This power. And how do you do that? As an linear, this is an exponent. What is the inverse of a linear module of linear is log. Now in y equals to what? E what? A plus what? So the power. Alpha E1 K. This is a mass model. Do it in the what? Econometric what? You get mass model S here, econometric model. Plus what? Beta E1 plus what? U. This is econometric model. These are it will be a linear model before power use. What the model will be linearized. Linear model, the model must be linear. It means that the beta 1 cap and beta 2 cap of what? To get the answer, it must be linear. You must unite the model, unite of the model. If not, OLS cannot work. OLS cannot run this kind of macro model. This is a macro model. This is an econometric model. The 2 different models. Yeah? But this one is removed. It's a macro what? Mass model. Number 2 property. The property of unbiasedness. The property of unbiasedness. What I mean by unbiasedness? The result you will get, everything is 100%, question is 100%, and the answer is 100%. Then you get